Alright, so you're going to start seeing more and more problems that integrate a bunch of different skills that you've learned throughout the years. And this one is using distributive property, so foiling. And also, do you understand how to simplify? Do you know how to simplify square roots? And can you combine like terms? So a lot of different things. I would say the easiest approach to radicals, because I think when I first taught this, I didn't emphasize this enough. But I would say before you start multiplying, adding, subtracting, etc., go ahead and simplify all of your radicals first. I think that would be the easiest approach to solving these radical problems. So before you even multiply, start to simplify. So I'm going to simplify square root 10 if I can, square root 40, square root 50, and square root 18, and then I'm going to multiply. And that will prevent you from working with huge numbers. So I'm going to go ahead and do that. I'm going to simplify everything first, and then I'm going to find the product. Square root of 10 is just 5 and 2, so that's just square root of 10 still. I'm going to write over here, so we have a little factor tree. I have 10 and 4, 5 and 2, 2 and 2. So it looks like when I simplify that, I'll have square root of 10 plus, you take out 1, 2, so 2 square root 10. And then here, for this next one, square root of 50, we're going to simplify 50. We get 5 and 10, 5 and 2. So we take out a pair, or we take out a 5. And we're left with 2 on the inside. Minus. Okay. Square root 18. 18 simplifies to be 6 and 3. 3 and 2. Take out a 3 with 2. What do you notice about this problem? What sticks out to you? You could. That's more difficult. What could you do that's easier than that? Something easier than foiling. Combine like terms. Don't you have like terms here and here? So rather than foil, actually, why don't we just combine our like terms? Now you could. And in this step, it would be easy, the foiling would be easier than it was before. But even easier than that, we can combine our like terms. So here, 2 and 1 make 3 square root 10. And 5 minus 3 is 2 square root 2. So really, this is what I'm taking the product of. Well, what's 3 times 2? 6, and then 10 times 2. 20. So I have 6 square root 20. Now, I have to break 20 down, right? I have to keep going. So, what do I do first? Simplify all my radicals. And then once I simplify all my radicals, I combine my like terms. If I can combine my like terms, then I multiply. And then once more, I see if I can simplify one more time. So you're always kind of checking if you can simplify at every step. So 20 is 5 and 4. So that's a perfect square. I have 2 and 2. So I have 6 on the outside. I take out a 2. And I have 5 on the inside. So I have 12 square root 5. Questions on that? Yeah, I know. It was difficult, that one especially, because you had to simplify one, two, three of those radicals. And then you had to combine like terms, and then you had to multiply. The first time I did this, I did it wrong. So yes, that can be challenging. Okay, so knowing that you have to simplify first, let's go ahead and approach number 2. Do you have any questions on number 1, first of all? Will I give you something on a test like this? Probably not at this difficulty level. Probably a bonus. But you should know. I mean, you should know that you have to just simplify. And this should not be out of your reach, is what I'm trying to say. Maybe on a test environment, it's a little too nerve-wracking. But it should be something that's doable. Okay, so for 48, we're going to break that down. We can't break it down 3. So that's 6 and 8, 3 and 2, 4 and 2, 2 and 2. So I have square root 7, parentheses, square root 3, plus, okay, what do I have when I simplify that? 4 square root 30. Again, what do I notice? Like terms. So I have square root 7 times 5 square root 3. What does that give me? That gives me 5 square root 21. Can 21 break down to pairs? No. Because it's 7 and 3 is 4 prime. Questions on this? This one, that is test-worthy, quiz-worthy. Okay. Alright, so today we're looking at 9.3, how can you use square roots to solve quadratic equations. This is another way to solve quadratic equations other than factoring. So, we're going to first of all speak on solutions of x squared equals d. All this means is, let's say we have a real number, so x squared equals 25. So this d value, if that d value is greater than 0, meaning it's a positive number, then you will have 2 real solutions. The one thing that everybody forgets for years and years, hopefully not you guys, is that whenever you take a square root, whenever you introduce a square root, introduce it, meaning it wasn't there before and then you put it there to solve, etc. You must remember you have 2 solutions, a plus and a minus, a positive and a negative. So, for example, if I'm trying to solve this, I know that square roots and squares undo each other, the inverse operations, right? Exponents and radicals, they undo each other. So, if I take the square root of a square, that undoes each other, right? And I just have x. That's what I'm trying to solve for. Well, if I do one thing to one side, I have to do it to the other side, right? So I'm introducing a square root. Anytime I'm introducing a square root, I have to remember I have 2 answers. A positive 5 and a negative 5. Why? Why do I have 2? It could be both. Isn't 5 times 5 25 and negative 5 times negative 5 also 25? Yeah. So you have 2 answers. And every year, people always miss the fact that you have 2 answers whenever you introduce a square root. If a square root's already there and you don't have to introduce it, then that's different. But if you're introducing it to solve, meaning it wasn't there before and you're making it there, then you have to remember a plus or minus. Let's look at the second scenario. It says when d equals 0. So if x squared equals 0, well, when will that be true? When x is what? 0. 0 and nothing else, right? So that's why you have one solution, one real solution, and that is whenever x is 0. Okay, let's say that it's less than 0. X squared equals negative 25. And you think of a real number such that this is true. No. 5 times 5 is 25. Negative 5 times negative 5 is 25. What you end up what happens here is that you have an imaginary solution. So it has no real solution. It has solutions, they're just not on the real number system. They're not on the real number one. They're imaginary numbers, which I'll talk about in algebra 2. So you don't want to say it has no solution. That's not correct. It has a solution. It's just not a real solution. And yeah, we're not going into philosophical debate on what's real and what's not real. In mathematics, there is such a thing as imaginary solutions, okay? So it has no real solutions. Again, having no real solution and having no solution are two different things, okay? So no real solution. Questions on that slide? All right. Okay, so when to use what method? Number one, if you're told solve by factoring, solve by factoring. If you're told solve by square root, solve by square root. Number two, the quadratic is easily factorable. So if it's really easy to factor, then factor, right? If you have a GCF and it's just easy to factor, like what multiplies to be negative 12 and adds to 4, that's easily factorable. We have negative 6 and positive 2. So factor, right? Whereas here, if x squared is set to a numeric value, so like we said, x squared equals 25, then you're going to have to use solving by square roots. You're going to have to introduce a square root to get x, right? X is positive 3 or negative. Does that make sense? Number 3, the quadratic is already factored. So if you already have something like this, the factors are x plus 5 and x minus 8, then you already know the value of x is negative 5 and positive 8, right? Here, this is a big one. Whenever the bx term, that middle term, is missing. So in standard form, we said that our polynomials are ax squared plus bx plus c. That you need to remember. 3 really big things you need to remember. Ax squared plus bx plus c is our standard form. Another one, a plus b times a minus b. That product is going to get me a squared minus b squared. The other one, a plus b quantity squared is going to get me a squared plus 2ab plus b squared. Oh, 14. And then a minus b quantity squared is going to get me a squared minus 2ab plus b squared. So these I've been telling you need to remember standard form as well. So when we have this bx term, that middle term missing, that's often an indication that we should solve by square roots. We add 15 to both sides, divide by 3, then take the square root. Number 4, the constant term c is missing. Why is this easily factorable? What can we pull out? An x, right. And so this becomes x times 3x minus 1 equals 0. You said that equal to 0, you said that equal to 0, and you solved it, right? You have a difference of 2 squares. I would say, either one at this point is pretty simple. If you recognize that this is x minus 9, x plus 9, from here, then you're good. If you don't remember that, then just add either one of both sides, take the square root, but remember that you have 2 answers. Okay. Again, number 3 is the big one. Okay, so other than the clear directions that say solve by using square roots, what is one hint that this might be easier to solve using square roots? Yes. Yeah, it is. The bx is missing, right? Remember, what is our standard form? Our standard form is ax squared plus bx plus c here. For a quadratic equation, right? I don't have a bx. I have an x squared, something x squared, and I have a constant term, that makes 27. but I don't have a bx. So to me, that's one indication that solving by square roots might be simpler. So, in this case, what am I going to use? How am I going to get x by itself? Add 27. So just like before, nothing new or magical. Add 27 to both sides. Use that addition property of equality. Those still matter. Now what do I do? Divide by 3. Then what do I do? Yes, square root, square root. What happens when I introduce the square root? Nope. X equals plus minus 3. Positive 3 and negative 3. Don't forget that. Now, it just so happens on this one, because there's a GCF of 3, you can, if you want to, solve by factoring. It's just a couple more steps, right? Pull out your GCF, that's a perfect square, minus, plus, x equals 3, x equals 3. Either method will work. Okay. You just need to know that you can't always solve every problem by factoring. You can't always solve every problem by square roots. Sometimes it takes one or the other. Sometimes you can apply both. Again, beyond the basic instructions, what do we have in these two problems that makes us aware that solving by square roots is easier? What's it missing? The x, that middle term. It's missing that middle term, so I should know that solving by square roots is probably an easier method. Now you could add, no, solve by square roots. So, first one, x squared minus 10 equals negative 10. What do I do? Add 10 to both sides. Based on that chart, what's our answer? 0. There's one answer, and it is 0. Okay. So next one. Negative 5x squared plus 11 equals 16. Subtract 11. Negative 5x squared equals 5. Divide by negative 5, you have x squared equals negative 1. What's the answer here? No real solutions. No real solutions. Questions? Sometimes you'll encounter a problem like this. Now, we know that, or we should know, this is this form, right? So I know that's a squared minus 2ab plus b squared. This is going to be x squared minus 2x plus 1. Yeah? Now you could, if you wanted, subtract 25 on either side, then try to factor it. That's complicated, right? We don't want to just say, okay, well, let's see. X squared minus 2x plus 1 equals 25. Then subtract 25. Subtract 25. Because I know in order to solve by factoring, I have to get it set equal to 0 first, right? So I'd be dealing with x squared minus 2x minus 24 equals 0. Then I have to factor that. Okay? So if you want to factor that, I mean, you can do that. You can try to do that. But rather than do that, if I have something squared like this, then just go ahead and solve by square roots. The whole thing is squared. So in other words, if you see something squared and it wants you to solve it, then solve by square roots. Because you know that's the direct inverse, and you'll be dealing with a linear function. So in this case, I have x minus 1 quantity squared equals 25. So how do I get rid of that squared again? What do I get? How do I get rid of the square? Square root. Okay. What happens when I introduce a square root? When I square root that, square root that. I get what? Positive or negative 5. You cannot forget both. What does that mean? That means that once you introduce that square root, you have two things you need to solve for, two linear equations. One of them is x minus 1 equals 5. The other one is x minus 1 equals negative 5. So what are your two values of x? You add 1 on both sides, so you get 6. You add 1 and you get 1. So 6 and negative 4. Which makes sense. 6 minus 1 is 5. 5 squared is 25. Negative 4 minus 1 is negative 5. Negative 5 squared is 25 squared. Does that make sense? Questions? I mean, the good news is you don't have to worry too much about, you don't have to worry about factoring in this case. Before, that was our only method. We're just adding a tool to our mathematical toolbox. Okay. Alright, if you're watching this, do pause it and try these problems. But here are the answers. Number 5 was tricky just because we have a fraction. But do you have any questions or we see any of this? Yes. Number 1? Okay. So, number 1. What do I do first? Divide by 3, negative 3. When I take negative 75 and I divide that by negative 3, what do I get? 25. So I have x squared equals 25. When I divide by negative 3, then what do I do? Square root. Square root, square root. I'm introducing square root, so what are my answers? 5 and negative 5. Any others? Yes. 4, 5. 5. Okay. 5. What do I do first? Okay, so that's what's the tricky part, right? Do I distribute first? Do I square both sides first? Well, the thing with this is, if you see a constant in front of the parentheses here, you want to get rid of that constant first. Okay? Because I can't just distribute like that, because I'm not just dealing with the 4 times an x minus 3. I'm dealing with the 4 times an x minus 3 squared. That squared screws everything up, right? So before I deal with the squared, I have to get rid of everything that's in front of it, right? Everything that's surrounding it. So I have to get rid of 4 first. So that's what I want to do first on that. I'm going to divide by 4 on both sides, and I get x minus 3 squared equals 9/4. Then I square root it. Right? So I'm going to take that, I'm going to square root it, I'm going to square root it. I introduced the square root, so I have two answers. So I have x minus 3 equals plus or minus the square root of 9/4. So when I do that, when I take the square root of something, what do I do? What's the rule? Square root of fraction. Square root of both the top and the bottom. So this is x minus 3 equals plus or minus the square root of 9 divided by square root of 4. So I have x minus 3 equals 3 over 2. Yeah? And then when I add 3 to both sides, what do I get? Well, I add 3 to both sides. Let's just do one of them. Oh, I have a plus or minus. Well, two things. I have two equations. X minus 3 equals positive 3 halves. X minus 3 equals negative 3 halves. Okay, are you with me so far? That's what I did. The only hard part is you have to add a fraction. You have to add 3 to a fraction. Okay. So when you add 3 plus 3 halves. Well, I need a common denominator, so that's going to be 6 halves plus 3 halves, which is 9 halves, which is this one. And then I'm going to add 3 to this one. So that's like 3 minus 3 halves. So that's 6 halves minus 3 halves, which is 3 halves, which is this one. We're just doing a fraction on that one. Questions on number 5. Can you do something like that on the scissor cups? Get rid of that number in front of the parentheses first, then square root. Remember your properties of square rooting fractions. Split them up. 9 over 4. Remember your plus or minus. You have two different linear equations, then solve the rate. Okay. One more thing, it's not really a thing, but we're going to talk about it. Sometimes they'll have you approximate your answers. So all that means is actually take the square root. And unless I tell you to approximate your answers, you're giving me a simplified round. Okay? If I don't tell you to approximate your answers, you're giving me a simplified round. If I tell you to round your answer to the nearest tenth, then just take the square root in your calculator. In other words, for this first one, 4x squared minus 13 equals 15. We're going to go ahead and add 13 to both sides. That's 28. Then divide by 4, divide by 4. I get x squared equals 7. I introduce my square root. So x equals plus or minus square root 7. Okay, so somebody take that in your calculator and you get to the nearest tenth. This is square root 7, so next one. 2.6. So your answers are, the one thing that people forget when they have to approximate answers is it's not an equal sign, it's a little squiggly wave thing. Okay. It's approximately 2.6 and negative 2.6. Remember, we have plus or minus. And that's it. Questions? We have a few more problems to go over tomorrow, and then we will review on Thursday 9-1, 9-2, 9-3, quiz final. Okay. All right. Here is your updated table of contents.